Now, let me ask you a question. Will you be given the domain most of the time?
No.
Yes or no?
Yes.
Yes, you will. Why? Because it's naturally assumed that what goes into an ice machine?
Water is the ice.
Okay, then why do people not take an ice machine and hook it up to a gas pump? Because there's no sense in it. Now, a lot of you say, what does that have to do with it? You cannot have a function if the domain is not what? Specified. Now, most of the time, if the domain is not specified, if I tell you, just graph the function, I am assuming that you're going to use any number you want to for the domain. I am not putting a restriction as an instructor. I am not putting a restriction on the domain. But if I give you a restriction on the domain, then I'm basically withholding, or I'm holding you back as far as the numbers that you can use. Now, if I withhold on the domain, that means you're restricted on the what? If I restrict you on the domain, that means you're restricted on the what? Range, because the range is dependent upon the domain. So your range on this problem will be from 4 to what? Nope. If the domain has a beginning and an end, then the range will have a what?
Beginning and end.
And it won't be infinity unless the domain is infinity. This one has a beginning and an end with a number. So your range will have a beginning and an end. What is your range? Well, this is 4. It starts at 4. I tell you, look down, up. So 4 to what?
20.
Good. To 20. And that's your range. Your range can only be in terms of what? Of what? Why, Hubert? You showed us that a while ago. You went through it 3 times a while ago, Hubert. Can only be in terms of y. Now, when I talk about increasing and decreasing values and all this good stuff in a few minutes, I've just told you that the only thing that's in terms of y is the range. I'm going to ask y'all what the increasing and decreasing values are, and y'all going to say y is equal to -2. And they ain't listen to a word I'm saying. This is the only thing that's in terms of y. This is the range. That's it. Everything else is in terms of x. Increasing and decreasing values. Domain. Everything is in terms of x except for the range. The range is the only thing in terms of y. And I think I've said that at least 4 times today. Somebody's still doing it, but I always do. So when is the range, when is the domain affected? Since the range, you ain't got to worry about the range because the range depends on the domain. But when is the domain affected? The domain effect is affected in 3 examples. Domain is, I don't know whether it's A, you English people can affected, I don't know which one, I think it's E, affected. Affected. I think it's A.
Say affected.
I think it's A.
If it's a verb, it's an A.
I don't know. Domain is affected, 1, by the instructions or instructor that can't spell. Meaning that the instruction tells you, graph the following function from -10 to +10. The range has been affected because what is affected? The domain is affected. When else is the domain affected? With a rational function What do you mean rational function? Well, what's the word for rational or ration or ratio? Or over ratio, huh? Fraction. Example, f of x is equal to 1 over x plus 2. Why is the domain affected here? That's not rhetorical. Because you can't have 0 where? So therefore, there is a number here that will blow the function up. And if there's a number that will blow the function up, then there's a number you can't what? You can't use. And if you can't use a number for input, the domain is affected. If the domain is affected, that means the range is affected. If you pour purple food coloring in your ice machine, or in your water that's going in your ice machine, what are you going to get? Purple ice. If you have a number that doesn't work in your function, what's the number? -2. -2 will give you what? 0. So you cannot use -2. You can use all numbers except for -2. Well, then what does that do to the range? It's going to throw a monkey wrench in the range, and there's going to be a spot somewhere on the graph that has an open circle or has a vertical asymptote. What about a radical function? And radical function, I'm going to put with even index. Why do I have to put that? And that's f of x is equal to the square root of x minus 2. That's an example of a radical function. Why is the domain affected on radical functions? And an even index. What can you not have in a radical with an even index?
You can't have a 2 or a 0.
A negative. You can have 0,
Oh,
but you can't have a negative. So here, like -3. Square root of -3, if you did that on your calculator, for the calculator drill team, people take it to the bathroom with them, all right, you'll get an ER-R-O-R. Pronounce it however you'd like. And that's when you quit the problem because you can't think, because you draw a calculator too much, and it gives you that error and you don't know what to do. You ever met somebody like that? Calculator gave us an error. Just quit. Go to the next problem. Can't think for yourself. Can't take the square root of what? Negative number with an even index. So again, the range is affected because the what? The domain is affected.
But you could take out I, right?
No, that's I is just another way, it's just a fancy way of writing the square root of a negative number. But yeah, you can do that, but we're not doing that right now. In other words, if you come up, if I give you this right here, and I say, what is the domain of that function? First thing you're going to do is set the radicand equal to 0, and find out that 2 will give you what? 0. 0 is okay. You can take the square root of 0. Square root of 0 is 0. What about 3? Or what about negative? Let's see, I said 2. I'm sorry. What about 1? Can't do 1. How about 0? Can't do it. How about -1? Can't do it. So what is our domain? All numbers greater than or equal to what? 2, Hubert. 2 minus 2 is what? 0. Square root of 0 is 0. 3. 3 minus 2 is what?
1.
Square root of 1 is 1.
1.
4 minus 2 is 2. Square root of 2 is 1.4. 3 minus 2, or I'm sorry, 3, 4, 5. 5 minus 2 is 3. Square root of 3 is 1.57. What's next? 6. 6 minus 2 is 4. Square root of 4 is 2. So the domain is not affected, and the range is not what? Affected. But if I plug in a -1, what happens? I get the square root of -3, and your calculator gives you a what? Error, depending on where you're from. See, if you're from around here, there's only one syllable in that word. Error. But if you're a teacher, you can't say that, so I just spell it out. E-R-R-O-R. Kind of like O-I-L. Because there's always going to be one person in the classroom that's perfect. And that person pronounces O-I-L perfectly. Even though they sound like they're from Pennsylvania and got tubes stuck up their guts. Oil. Okay? So, now you can all figure out how you say O-I-L. To yourself, please. All right, so if I give you a function, first you're going to see if I change the domain or range. If I don't say, then it's all up to you. So let's take this function. F of x is equal to x squared plus 4x plus 4. Automatically, you know that the answer for the domain is all real numbers. Why?
So you got a parabola for a
Is
quadratic.
there a rule that says parabola is all real
No.
numbers?
No.
Well, why is the domain not affected? Because the only way that I can affect that domain is by the instructions or the instructor. In other words, I tell you the domain is -4 to +4, or the directions say only use -4 to +4. Why is it all real numbers unless that number 1 happens? Why is it all real numbers? Because it's not a radical, and it's not a what? It's not a radical or rational function. Well, Hubert, are you telling me that if it's not a radical or rational function, then the domain is always going to be all real numbers? Yes or no?
No.
Yes.
Yeah.
That's why you're going to fail. Okay? All real numbers, unless what? The instructor or the instructor changes it. So I can give you these all day long. What's the answer going to be for domain? All real numbers. What about this? What's the domain? All real numbers. Why? Because it's not a rational or radical function. Can I plug 0.5 into that problem? Yes. Can I plug 1/2 into that function? Yes. You can plug anything you want to in it because 1/2 squared is 1/8, or 1/2 squared is 1/4, and 1/2 to the 3rd power is 1/8. You're not going to get something crazy like 1/0 or the square root of -1. Anytime you see a function, I could give you f of x equal to x plus 2, all real numbers. Unless I put something in the directions or on the test or I say it. You can only use -5 to +5. Then I have affected, or the instructions, if the instructor has affected the range, or the domain, which affects the range. Now, you got to be careful here because, let's take this first one here. Because you would do this on a calculator. You wouldn't graph this. You would just do it on a calculator for those calculator drill team people. You know, dang old, call you dang old calculator name. My calculator's name is Charlotte. Y'all laugh. You ever seen people who can't make change can run the cash register? Those are the people I'm talking about. Don't raise your hand. Don't say nothing. You're going, I didn't say nothing. I don't know any of y'all. Oh, you talking about me? Shut up. You ever met somebody, bill is $11.57? You give them a $20 bill and 7 cents, watch your head explode? Your calculator dependent. I do it all the time, just to see if the person is running the cash register. Let me ask you something. If you owned a business and you had a person running a cash register that couldn't make change, what does that make you? Not smart. Because if that person can't make change, what's going to happen to that register every night? It's going to be short. And about the 3rd or 4th time, what are you going to do to that person? Fire him. Ridiculous. Anyway, this thing looks like this. So the domain is all real numbers, and the range is from 4 to what?
Infinity.
Now Hubert, how did you know that? Well, that's what we're going to be doing the next 2 weeks, is I'm going to show you how to do that. Without using a calculator, but just using that thing between your ears called, don't sneeze. No sneezing in class. Okay, trying to teach. All right, thing between your brain. So let's just go ahead and get started on that. Now, this is where I go a little bit against the syllabus. We're going to start completing the square today. Okay? And that will cover all the way through at least chapter 2? I think all the way to chapter 3. But I'm going to teach you how to do completing the square. And then we're going to spend the next 2 weeks on doing completing the square until you are sick of doing completing the square. 2 reasons. One is when you get to first variable calculus, you'll be able to throw up one of these in a few seconds and be able to know what it's doing in a few seconds. Versus the person trying to put it in on a calculator. 2, you're going to have to use complete the square in first variable calculus to do the denominator of some of your things that's under a radical, like something x squared plus blah 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 under a square root that's in the denominator. And the best thing to do is make a binomial square out of it. And the only way to do that is complete the square. So completing the square is very important. Another thing completing the square does, it not only gives you the x-intercepts, but it also gives you the vertex. In order to get that with the quadratic formula, you have to use two more formulas. Okay? Quadratic formula. When do you use the quadratic formula? When you have this. This is when you use the quadratic formula that they drilled you on in high school so much. 2.25 x squared plus 3.75 x plus 2.3. That's when you use the quadratic formula, when you have decimal notation in your quadratic. When is that? Hardly ever. But why do they teach it to you? Because you can use what? What do you use with the quadratic formula? You're supposed to say it. Your calculator. And if you use your calculator, you won't make any stupid mistakes, and you'll make a what? Better grade. But you won't be able to make change when you get in the real world. So we're going to do it this way. We're going to do complete and square. So let's take x plus, and yes, you can factor this, and let's go over that right quick. To get your x-intercepts, there's several ways to find the x-intercepts of a function. One is to use the reverse FOIL. And set equal to what? 0. Because your y is always 0 for your x-intercepts. You know that. So you're always going to set it equal to 0. 2, your shortcuts. Remember factoring using the shortcuts? 3, the quadratic formula, which we just said is pretty much worthless because it makes you depend on the calculator. And then there is completing the square. Now a lot of you, if you've had algebra before, you remember doing these two. And then you had the high school teacher that made you sing the little song, x is equal to square root, da 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 da. This is stupid. Okay? That's stupid. This one should be taught last as far as importance. Okay? These are only doable if your trinomial is what? Factorable. Which one is not restricted at all? Completing the square. So I could either teach you 3 or 4 ways and you can only use 3 of them, or I could teach you one way and you use it all the time. And that's the way I do it. I teach you to complete the square and you use it all the time. Now I realize, I'm a math teacher, got a couple of degrees. I realize that that is x plus 2 quantity squared. I don't need a freshman student telling me that, okay? So I know that. I'm doing it to show you the relationship. So, f of x is equal to x squared plus 4x plus 4. First thing I'm going to do is set it equal to 0. X squared plus 4x plus 4 is equal to 0. Now this is where you need to write down in your notes what I just did. Set equal to 0. Why? Because when you find your x-intercept, what is y? Always 0. So I'm setting my y equal to 0. Where's y? F of x. Okay, don't mess that. Now what I do? Well, do y'all remember ax squared plus bx plus what? C, Hubert. That's right, class. This is C. So this is number 1. Number 2, move C. I always love this step because I say move C, and I always have a student raise their hand, and what do they ask?
Let's see.
Well, no, besides that. What do they ask after I tell them what C is?
How?
Where? Okay, well, let's go over the concept of equals. How many sides of equal sign are there? 2. C right now is on the left-hand side, right?
Sure.
If I tell you to move C, what's the only possibility for you to move it? To the right-hand side. Do you see what I'm talking about? Where I'm going to move it up. There's only 2 sides of an equal sign, left and right. If I tell you to move C, and C is on the left-hand side, there's only one place to move it. It's like I told my 8-year-old last night. Think before you ask, because most of the time you can actually what? Answer your own questions. Move it. So here we go. And 3. Add blanks. So here we go. X squared plus 4x plus blank is equal to negative 4 plus blank. Now, there are several ways to teach completing the square. This is about the 3rd way of teaching. I have taught for a while, 20 years, close to 20 years, and this is the way that people like it. Now, you may not like it right now, because nobody likes it right now, because you don't like complete the square, because you've never been taught complete the square, or some of you have, and that's good. But some of you are like, what? Just bear with me, it'll be all right. This is the easiest way for me to teach it. I could teach it to you all on the left-hand side, on this side, right here. But I have found that when I teach this, students like this better because it's more structured. Versus on the left-hand side, it looks more unbelievable on the left-hand side. So just bear with me. Now here is the most important part of completing the square. This is 90% of completing the square right here, number 4. It's in red. That means I need to highlight it in my notes. Take B, divide by 2, and what? Square. B divided by 2 and square. So I'm going to do it in red. And what do you think is going to go in the blanks? That number. So I'm going to go over here and I'm going to say B divided by 2 and square. B divided by 2 and square. So you need to do this in your notes and highlight it. Or just wait and watch the video 5 or 6 times. Now in this case, what is B?
4.
4. Divided by 2
squared.
is 2 squared, which is
4.
So that 4 is going to go here and here. So I'm going to rewrite my equation. X squared. X squared plus 4x plus blank is equal to negative 4 plus blank. And I'll take my red and put a 4 here and a 4 here. Now, as I told you before, this one was factorable. So that's why you're getting these repetitive numbers. It's not always going to be like that. Now, after you do number 4, you will have shortcut number 1 or number 2 on left-hand side. So now you have on the left-hand side shortcut number 1 or number 2 based on the sign of the 4x. So what does that give you here? What is that? X plus what?
4x.
X plus 2 quantity squared is equal to 0. Now this is where I have to throw in. Remember me putting the shortcuts up for y'all the other day? And I told you, if you don't know these, you need to learn them or see me after class or see me during office hours, because you're going to see them until you get out of mathematics. Which for some of y'all, it's going to be a while because you're engineering majors or science majors. And that's going to be statics and dynamics. And when you get out of statics and dynamics, you may be through with math classes, which will be Calc 3.
I realized myself I've had to learn, relearn a bunch of stuff in geometry just working in an engineering office.
Yeah, you do.
Because you may know, like someone may dimension a blueprint and they may show radius.
Mhm.
You may know it's a 90-degree angle.
Mhm.
You may know one side, but you know.
Yeah, there's a lot of, and math is one of those things that if you don't use it, guess what? You're going to suck at it if you don't use it every day because it gets rusty. And some of y'all haven't been in school for 5,000 years, right? That's what y'all tell me when I haven't been in school for 5,000 years. I don't forgot how to do this. Shut up. All right, it ain't been no 5,000 years. All right, so take this. We're going to take this over to the next page because you just keep writing in your notes. I don't think that copied. Okay.
This is my last piece.
There we go. Mr. Lou. Is Mr. Lou out there?
Yeah.
You waiting, Mr. Lou? What time is it, Mr. Lou? I can trust you.
No idea.
Okay, you suck.
3:49.
All right.
It's 58.
It's what?
3:58.
What time's class over? Huh?
It's 3:49.
See, that's why you're going to fail. Mr. Lou, you let me down.
I said 3:48 and then.
No, you didn't. You said, I don't know. You said, I have no idea.
Oh.
All right, it's 10 to what, 4?
Yeah, I think so.
What time's class over?
55.
How much?
55. In 5 minutes.
Okay, 5 minutes.
It's 49 right now.
I don't know. I can't tell what time it is. All right, at this point right here, you got two things. You got your vertex written in two forms. All right, one is just get the vertex written, take the opposite of both numbers. What numbers? Well, there's only two numbers in that problem. Where are they? 2 and what? 0. Well, what about 2 up in the corner? That's an exponent. That's not a number. That's an exponent. I didn't say exponent. I said numbers. All right. So take the opposite of both. This is one form of finding the vertex. And that's -2 and 0. So there's your vertex. And you could say -0, but there is no such thing as -0. But if that was a 4, then it'd be -2, -4. If this was a -2, it would be -2, +2. It's always the opposite of both for that. If you do it in this form. If you do it in this form, f of x is equal to x plus 2 quantity squared minus 0. In other words, you bring this over and set it equal. This is called intercept form. Sometimes the homework or the test will ask you to put the vertex in this form. Here, you take the opposite of this guy, take the opposite of that guy, and just bring this down. Okay, bring down. And this is the opposite. Now, a lot of you say, well, I like the top one. Well, most of the time, this is what you're going to use when you're drawing your, most of the time, you're not going to sit here and say, okay, I'm going to draw the parabola, but first I got to put it in intercept form. No, you don't have to do this. This is what you'll use when you're drawing. So most of the time, that's what you're going to use. This is what you write for a test or homework.
You need to bring down the negative too when it's a 0.
This is, you do the opposite. That'd be
No,
negative.
I mean like the negative on the 0.
No, I was just, if this was a negative, if this was a -4, you would just bring it down -4.
Oh, okay.
You just bring down. You don't
I got
take
you.
the opposite. That's why I did that. I'll change it. I mean, we'll do another one when y'all come back and. All right, now that's what it'll give you. It'll give you the vertex, and then it'll give you your x-intercepts. X plus 2 quantity squared is equal to 0. And now you just, what? Solve. So how do you solve? You got to take the square root of both sides. And that's x plus 2 is equal to positive or negative 0. Now this is important. I need you to take a highlighter and highlight that and this. Now with 0 it doesn't matter. But what's the square root of 4?
2.
Positive or negative 2?
Positive.
What's the square root of 9? Positive or negative 3? And that's going to make a difference because you got 2 x-intercepts. Positive 3 and negative 3. There's 2 x-intercepts. So x, bring that 2 over. X is equal to positive or negative 0 minus what? 2. And that's where you get the 2 x-intercepts. In this case, 0 is 0 no matter what. But if this was a 1, you'd have positive 1 minus 2, which is negative 1. Negative 1 minus 2 is negative 3. So you have a negative 1 and a negative 3 as your x-intercepts. In this case, it's what? X is equal to 0 minus 2 is negative 2. So this is your x-intercept. So your graph looks like this because your vertex and your x-intercept is the same thing. Does that happen all the time? No, it does not. Your y-intercept, let's go back to the original problem.